here we are. Thank you very much again for being here. Day number 3 of this training course. I'll try to be brief. My activity is thought to be conducted in 1 hour and a half. I'll do it in less time, and I'll try to make it practical for you to interact with the material or with these concepts. The concepts that I will talk about, actually they are methodologies of ways of teaching. They are individualized paths for learning, that's one. Also known as personalized learning paths, on the one hand, and also problem-based learning. Question for you, are you familiar with problem-based learning? Do you apply it in your classroom usually? Yanis, yes?
Yes.
You do apply it?
It's my job now. I applied it as my job in the STEAM school, yes.
There we go. So yeah. Concepts related to STEAM, before STEM, yeah. Now STEAM, so it's science, technology, engineering, arts and maths. So yes, and now our learning environment is changing with the new technologies. The world is changing, we need to adapt to those changes. So that's more or less what I'm going to talk about. Okay, so problem-based learning, more simple, well, simple. I try to avoid simple, difficult, these two terms, but like at least I use problem-based learning in my teaching. Individualized learning paths are more difficult to implement because they require a little bit more time in the previous stage, meaning planning. I don't know, besides Yanis, anybody else applies problem-based learning in their teaching practice? Sometimes, okay.
Children need to adapt problems they are teaching.
Okay, so sometimes, okay, great. I mean, I thought this would be something like, no, we already know this material and this is, okay, so this is great. So, a turning, oh no, I have mine. A turning point in the teaching culture. So, before teaching, teacher-led teaching. So, the teacher was talking, it gave all the information to the students only absorbed, and then now we're changing to child-centered learning and experiential education. When we talk about experiential education, we talk about Maria Montessori, trailblazer, excuse me. So Maria Montessori, Italian physician and educator that revolutionized childhood education. And she had a theory, she developed a theory that said that children have natural tendencies for learning. And the more experiential, excuse me, this word is very difficult. The more experientialized it was, if I may say that word, the better. So individualized learning plans gain a little bit more traction in the mid-20th century, so the 1900s. So Maria Montessori emphasized that students have absorbent minds and they effortlessly learn from their environment if they are exposed to an environment where learning can happen. No? So we have to stimulate children's senses and facilitate understanding. So why was it important then? I have a video that I can show you. It's actually in Finnish, but I think it essentially captures what happens in a classroom where there is no, I mean, when teaching, it's only done by the teacher. What I'm trying to say is that the teacher only gives information and the children only absorb. This was we're trying to avoid this type of teaching per se. So I will talk, as I said, it's in Finnish. So we have a problem, the students absorb, some of them come up with answers. This is like level number 1, very basic and easy. So problem number 2, okay, so great. Now we have a student that doesn't quite understand what's going on. Okay, so this type of teaching obviously is one size fits all. It doesn't take into account students' individualities, inclusion, etc. So this is what we're trying to avoid, and this is what happens in a classroom. So then we have another level of complexity, and then, okay, we have 2 confused students. Okay, so this is the teaching scenario. So children learn something at school, they go back to their homes, and they try to apply what they learn in class, failing massively. Again, they come back to school with many more doubts, or not. Remember that math is sort of like, maths and languages are sort of like a staircase. So you have to learn the first level in order to go to the second level, because the knowledge that you acquire on this level, you will apply it over here, and then over here, etc. Does it make sense? Well, yes, more or less? Okay. So this is what we're trying to avoid. So I'll go back to my presentation. Present. So, why was it important now? Because this method, it can be improved, everything can be optimized. So, why is it important now to teach in a problem-based, with a problem-based methodology or with individualized learning paths? Because nowadays, as I said, the world is changing, technology is changing very rapidly, so we need to teach students, or we need to we need to teach human beings to be constantly learning.
We need to mold them.
Yeah, we need to mold them, thank you very much. So we need to mold our students to be constant learners, to be constantly engaged, and constantly, essentially we need to teach creativity, responsibility, and the ability to learn, or learning to learn, throughout their lives because of globalization. So, the difference between individualized learning paths and problem-based learning, one is tailored learning, so individualized, tailored to a specific individual, or personalized to the individual's needs. And then problem-based learning, it engages students. So you present a real world problem or a scenario, and then students solve it, per se. So that's what we're trying to do. Again, individualized paths to learning, individual to the needs, to the interests, to the abilities of each student. Accessibility, inclusivity, etc., etc. So this is an example of an activity of an individualized learning path. So in an inclusive classroom, we have different plans for students with different disabilities and learning difficulties, or different types of learning. I don't know who was the one that mentioned, but somebody mentioned personality types, but also, I don't know if you're familiar to Gardner's different types of learning, meaning is it visual, if either you are more visual, or you are more, you learn better listening to things, or you learn better reading, or you learn better by doing. So individualized learning paths, the same task can be applied in many ways, either in a visual way, You can use an audio, etc., etc. So, it's individualized because it takes into account your diverse classroom. So, the quote-unquote children that learn really fast, the children that struggle, the ones in the middle, etc., etc. Till this point, yes, and understood? Yes? Am I being clear? I mean, at least,
yes.
Am I being clear? Yes? Okay. Thank you. So, in an individualized learning path classroom or a task done through this method, the first step is always assessment. You always have to assess the base level of your students, more or less. Assessing is really, I mean, at least to me, assessing things is really difficult because I always try to avoid the dichotomies or black and white thinking, no? So fast learner, slow learner. I hate that. I always try to have parameters and graphics and rubrics in order to say like, okay, this particular skill is what I'm trying to assess or review, or it should be taken into account. So, step number 1, formative assessment through quizzes, short tests, online platforms, Kahoot, whatever. So that way you more or less rank, okay, so who are the ones that have the knowledge and need to pair it up with the ones who don't. So they need to, in a peer-to-peer scenario, they need to help each other, etc. So, as I mentioned, rubrics and checklists that align specific skills and knowledge that the students should demonstrate. Remember the rubric that I showed you, the success criteria, those are great pieces of information. You give them to students and you say, this is expected from you. You should know this, etc. Or this is the path, or this is what I want to achieve. And then children have an idea, or students have an idea of what is expected of them. Step 2, based on your assessment, you design an individualized learning plan. One of those ways could be either peer-to-peer learning, meaning in a problem-based scenario. And I'm mixing two approaches, but they could easily be intertwined.
I need to mix them because we have in every classroom we have someone with inclusion disabilities. So we need to combine these two.
Yes, of course. I mean, it doesn't mean that when I speak of them independently, it doesn't mean that they cannot be applied simultaneously. So, for example, you in your how you do it, you can start with activities peer-to-peer learning. So after your assessment, so you rank more or less, okay, who is a fast learner, who is a slow, and I'm speaking again, dichotomy, black and white, but okay, so quote-unquote fast learners, so I pair them up with slow learners per se, so they help each other. I also take into account that students are more visual, so my presentations, visual, colors, graphics, I don't know, maths problems, a rubric, a figure, shape, etc. These are just ideas. So students with learning disabilities receive additional support through specialized aids. So after you assess them, you already know more or less what gaps in their knowledge should be addressed. So you individually go. And this is all, obviously this is all very, I mean, in the day-to-day, I know it's very difficult. It's not always possible, but at least you have to have it on your mind, and then you implement it step by step, each day, a little bit more, a little bit more. So challenging your opportunities for high achievers, so you always have like your exercise, one exercise, and then you have another exercise that it's a little bit more complex, per se. And catering to different learning styles. Visual learners, give them more graphical representations, auditory learners, hey, maybe an audio, a video, etc. Excuse me, I always forget that I have to click. Okay, that's individualized learning paths. Now, problem-based learning, active. You give your students a real-world problem. Hey, collaboratively work together to solve it. But these types of activities also encourage a lot of critical thinking and deeper understanding. So, go back. So your students are you are not giving them information, they're the ones that finding solutions. They just have a problem and they find the solutions to the problem. So, engaging, these types of methodologies or ways of teaching or ways of conducting activities are more engaging for students. They are active participants in their learning, and you can pair up diverse teams and individualized strengths. So, problem-based learning fosters problem solving and critical thinking. Perfect. So problem-based learning fosters problem solving and critical thinking. This is an example. And I would like for you to play out this, where did it go? I would like for you to play this example. I want to recreate this activity. So, planning an inclusive school event. Organize a school event accessible to all, where students with learning difficulties play a active role in the process. Meaning, organizing the event, calculating how much would it cost, what do we need, the amount of things we need, etc. So, activities, fundraising, budgeting, coordination, maths applied in a real-life scenario, a real-life problem. We have a problem, we need to organize a party, a festivity, or whatever. Okay, so you solve it. And it has real-life applications with or various mathematical concepts. Collaboration to address challenges. So these are examples of problem-based learning, taking into account inclusivity and accessibility. So students with dyscalculia, they focus on budgeting with the help of other students. How? Collaborating with peers. Diverse teams with unique strengths and perspectives as well. You pair different types of abilities, learning styles, etc., etc. Okay, as I was saying, I was talking about intertwining these two approaches, so they can be, of course, they can be mixed together. So this is an activity, and I want for you to play it out, or for you to practice it. So activity number one, real-life application. Assess students' ability to apply mathematical concepts in a real-life scenario. We have already done that in previous activities, of course. Procedural they need to demonstrate procedural fluency, strategic or competence thinking, strategic thinking. These are the two, per se, success criteria that I want them to achieve or I want them to reach. Okay, so I have a rubric with these two particular concepts. They have their own explanation. I'll go further. So mathematical problems. For example, plan a shopping list and calculate the total cost, including discounts and taxes. I don't know if we were talking about yesterday. We were talking about it yesterday on the, MasterChef. We were talking about. I don't know if we talked about discounts or taxes or just costs. No, or it was the Cyprus Mathematical Society's costs. Okay, so well. You add a little bit more of complexity if you start thinking about taxes and discounts, meaning like, hey, it's better to buy a big bottle of olive oil in a liter instead of like a small bottle. Optimize. Till this point, am I being clear? Yes? Yes. Thank you. So this is the rubric that I use. These are the things that I want my students to achieve. So it was procedural fluency, so skills a skill to carry out the procedure flexibly and accurately. So they have a tool, imagine the rule of 3, they know how to use the rule of 3, and they know how to come up with the correct solution. That will be number 1. Strategic competence, ability to formulate, represent, solve mathematical problems. Hey, we have a discount, 50% discount. Let's apply it. You do the calculation, rule of 3 or whatever. Selling my models. You have the tool, you use the tool and you think strategically. And I don't remember, let me go back. Yeah, those were the 2 competencies that I wanted them to achieve. At least you have a picture of what you want or what is expected of them. Obviously, you don't present this information to your students. It's too much. It's overly complicated for them. Like, this is for you. Okay, assessment criteria. These are more criteria, which is more or less the same as the ones before. You have more assessment criteria over here. Okay, now it's your turn. I would like for you to create a problem-based learning scenario. So you ideate a warm-up exercise. That is your assessment, step number 1. Oh, more criteria. This is my rubric. Step number 2, you ideate a problem-based learning scenario as the one that I mentioned, a shopping list for a school event to calculate costs of the items you will include on your shopping list. If there are discounts, also the representation of, hey, we decided to buy this bottle of olive oil instead of this one because there was a 50% discount, etc., etc. This is an example. So have your students calculate the number of gallons of paint for a 4.26 per 487 room. Remember the lesson plan with the rule of 3 that you had an exercise, the art exercise that had these types of activities to calculate the area of a room that you should paint. So more or less is everything that we have already applied, but now we are putting words, we're naming it. We're able to name these type of things. That's it. And then present. You present your math problem to the other team and vice versa. Okay. So what we're going to do is the following. So you divide in teams of 4. Number 1, or step 1, you create a warm-up activity. So what you want to do is for children, or to assess procedural fluency. Okay, so how fast can your students calculate something? Problems, arithmetic, think about that. And then that's step number 1. And then step number 2, you present a problem-based scenario. Meaning, a problem-based scenario could be the example that I just presented. Calculate the number of, you need to paint a room. You need to calculate the area of your room. You need to do a, what's it called? You need to prepare a event at school. Calculate the shopping list. So, okay, so can anybody tell me, I mean, in your own words, can somebody explain to me what is there to do? What is your task right now? I mean, here, as a practical activity.
And we need to do the tasks for our students.
Okay, great.
Problem-based learning.
Yes.
Or some shopping list or something.
Okay, so, perfect.
Warm up.
Exactly.
Problem.
Great. Great.
Solution.
Perfect. So, you are teachers. You're gonna gather in groups of 4 people. You're gonna create a warm-up activity to assess the criteria that I will put on the whiteboard, and then you have to come up with a problem-based learning activity, and after that, we're gonna give those activities to another team, or we're gonna peer review our activities. Does that sound right? Is it clear? Perfect. So, paper, computer, whichever you like.
Actually, do the math.
If you have a discount on
And that also includes the painting. Okay, classroom operation. Ask for the measurements of the classroom. So that's
Just a quick overview of what
three of them.
Okay, so for the warm-up activity, they are written here, and then we thought about a tank with fuel. You have all the dimensions of the tank, the length, the width, the height, and the height of the level of the fuel, because it's not completely full. And the capacity of the tank being the number here given, the children would have to calculate which is the minimum number of transportations to empty that tank, only to the height that is full of fuel. And also, if the price, you are given the price of 1 liter of fuel, they have to calculate the profit obtained by selling the amount of fuel mentioned above. So not a full tank of fuel, but only the level there. That's the idea.
Okay. Okay, perfect. To who do you want to give it to?
Anybody, it's not a problem. Who doesn't have a problem?
You have a problem. Okay. So, you want the birdhouses? Yeah.
the one solved example, and the items like windows or blackboards, they need to place on the right place on the blueprint of the wall, and maybe measure the area they need to paint. Of course, with one example that is solved and where the procedure they need to do is given already. Finding the prices and why did I choose that color and not any other is also something that they can debate without any big knowledge of math. And are you going to paint it yourself, something that can be also done in debate. With triangle flags, maybe the students who are faster learner, they can draw the isosceles triangles, and the rest of the students who are with inclusion, they can cut it out, or they can do something. And from the rest of the paper that is left, they can make other shapes to decorate the classroom. And also the activity we were thinking of regarding the shapes, we can give them pengrams. You are all familiar with it. And shapes they need to make from these types of these shapes, and we can decorate with the decals. We like it because it's very applicable and it's very it's a real life problem, and they would love it because they are decorating their own space where they are every day. So it will be nicer for them.
Okay. So, thank you very much, Marina. I have already extended my time. So if one or two more teams would like to say what did they like about the exercise and how would they implement it in an inclusive classroom, it would be great. So whoever wants to participate.
Can we see?
Yeah, because I mean, I'm already behind schedule, so I'm sorry, but
Thank you, Team 1, for this excellent idea, because we really liked it, and I'm going to explain why it gives us a lot of, as teachers, it gives us a lot of new things to do in class, and project this from problem solving to project, from problem learning to project learning as an extension. We had to do as you remember, we had to do the birdhouse from a piece of plywood. That is given. It's 110 by 45, 120 by 40. The dimensions are there. They are given. First of all, we decided to call it an Airbnb hotel because it's going to be maybe for bees at the end of the project. So anyway, we see that from every plywood there's going to be a 20% waste of wood. So that means, after doing some calculations, that from every 5 bird cages from the waste we can do another bird cage for free. Of course, we completed the table as students, and we saw that the 6th bird cage is going to be for free, but these questions are very nice because they leave room for debate, because some pupils will think that the 20% of waste, if added together, of course it makes 100%, but maybe the pieces will not be good pieces for another bird cage or bee cage. We have nice questions there asking about total prices and things like that, and how many bird houses can we make with 80 euros. We do some nice calculations. And then we are given another piece of plywood with different dimensions, and we're asked which one is more suitable or more, economically is more cheap to make. Of course, the second plywood now, it looks a bit cheaper, but again, there is a big